We have an isosceles triangle lesson. In isosceles triangles, as you know, once you know that you have two sides of a triangle congruent, you can call the triangle isosceles, which also gives you some base angles congruent. So that's a really nice thing to know if you have an isosceles triangle in a picture, or if you have parts that give you an isosceles triangle. So we're going to take a look at a couple here, and again, I'll let you try a few on your own, and you can bring them in and let me take a look at them. The first one we're going to look at is one where you're given a lot of information. We're trying to get triangle ADF, which is this little triangle down here, congruent to triangle FEC or CEF. And if you look at what we have, let me go to the drawing here. We know that, and again, in the last lesson, which is overlapping triangles, these two triangles, I'll just put a dot where they are. These two triangles are not overlapping to each other. So they're separate, so you can see them pretty easily on the picture, but if they were overlapping, you may want to redraw them. But what we know is we have, this first given is interesting, because the first given is BA is congruent to BC, which is telling you that this piece is congruent to that whole thing. Now these two long pieces aren't part of these little triangles that we are trying to get congruent here. So what we're going to do is notice that if we have these two long pieces congruent, this big triangle BAC is isosceles, which means this angle and this angle down here are congruent, because in an isosceles triangles, these two base angles are congruent as well. We also know AD is congruent to EC or CE, and they tell us that F is the midpoint of AC, which gives you these two pieces here at the bottom. So we are looking at a side angle side proof. Of course, we just need to write that up. And so we'll go ahead and do that. Let me just get rid of some of this stuff here. Okay. And we'll get into the writing up of the proof. So, of course, our first thing is to put our givens in. And let me just kind of copy these, paste them in. It's going to kind of have a weird formatting. Just give me a second here. And after we have our givens, we need to then take a look at the things we labeled. Okay, and these are givens. All right, step 2 here would be to label anything or write in anything that we labeled that weren't necessarily specific in the givens. For example, we know that AD was congruent to EC, so we don't have to do anything with that. It was just given. But BA congruent to BC, that's going to give us angle A is congruent to angle C. So we have to put that in here. All right, let me just get down here to my symbolic stuff. Okay, we have angle A is congruent to angle C. So I'll just kind of copy this. And the reason for that came from the fact that this triangle we knew is isosceles because of the two congruent sides. So this would just be isosceles triangle theorem. So that's what you would put when you know that these two angles would be congruent based on the fact that the sides of the larger triangle were congruent. Okay? And from here, since we have right now the angle, we have DA congruent to EC, we just got to get this midpoint thing down. So this is where we'll say FA is congruent to FC, and the reason for that is definition of midpoint. And finally, we can now say the triangles are congruent by side angle side. So I can make this statement here. Let's grab all of that there. Okay. And this is going to be side angle side is congruent to side angle side. Okay, so that's how isosceles triangle theorem works. I'll do another one here. This is the one where they're actually telling you that it's an isosceles triangle. Okay, so that one, quick little four-step proof, wasn't too terrible. Let's take a look at number two. Um, while you're labeling or trying to figure out what you need to do there, you can write this in. I'm just going to take the givens and let me just put all this here. Okay. And this is given. This here. Okay, and get step 2 ready here. Get this step 2 ready here as well. Okay, let's look at what we've got. Isosceles triangle cab. So this original triangle, the big one, I should say, is isosceles. And when you have an isosceles triangle, not only do you get the sides, right? Triangle cab is isosceles. I mean, you do get the angles as well. We may only need one of these parts. Let's just kind of see what the other pieces are. So we had AC congruent to AB, and then we have R is the midpoint of CB. So if R is the midpoint, you get this. Right away, we can do a side angle side proof, but don't forget, we also have the reflexive piece here. So if you don't want to go with these angles, you could go with side, 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 or you can go with side, angle, side. And I think I'm just going to do it that way just to kind of focus again on the isosceles component here, because that's what we're practicing in this proof. But just note some of these proofs can have different ways of proving it. So we already know that AC is congruent to AB. Check, that's already in our proof. Let's get this angle C is congruent to angle B. And I'll just kind of grab this here. Okay. So we're going to say angle C is congruent to angle B, or angle B is congruent to angle C. This is isosceles triangle theorem. Put a little triangle in there. Isosceles triangle theorem. And in step 3, we are going to use the midpoint. So R is the midpoint of CB. So I'm going to say that RC is congruent to RB. And the reason here is definition of midpoint. And finally, in the fourth step, since we now have everything we need, we can say that these two triangles are congruent. And the reason for this one, as we saw here, was side angle side. So I'll put that in here. Side angle side is congruent to side angle side. All right, so you can try some of these other proofs out, dealing with isosceles triangles. They're telling you some stuff here. You got a bisected angle. That might be a good practice to do. I don't know what happened in 4. Right now it looks like the diagram isn't there. Oh, there it is. Not sure what just happened there, but there's the diagram. Sometimes it does that in Microsoft Word. So you can go ahead and try a couple more of these out. I think isosceles triangle proofs aren't terrible. It's just an extra component that you get in these lessons and more practice writing proof. So give these a shot and good luck, and let me know if you have any questions.